Hi guys, we'll start now. Uh, I hope I'm clearly audible and the screen is visible. The presentation is visible. If anyone could quickly confirm. Okay, cool. Yeah, so let's get started. So I'll try to keep this session a bit short. I don't want to dive into too much detail so that people get scared or anything. So today we'll mostly be talking about what serverless is. Like people have, you deploy, make your applications, you deploy it on a server, but serverless, when people hear it, it seems pretty weird to most people. And today we'll try to understand what that means and how do you go about making your own functions to run on serverless services. So just a meme for fun. Either you spend a lot of time managing your own servers or you go the serverless route. So if we try to understand how this evolution happened, if you go back a few years in time and when you wanted to, let's say, deploy your own website, or even today you want to deploy your own website, and say you go buy a computer, let's say you buy your own PC, and you go ahead and install everything on that PC, and you set up your web server for your website or any form of computation that you want to have, which is client facing, right? So what you would do is you would go a bare metal route. You get a fresh computer, you set everything up. So you need to take care of everything. You need to take care of upgrading the storage, changing the storage, allocating the resources like the compute and everything. And apart on top of that, you need to manage all the security features, like what kind of firewall do you need. You need to constantly keep updating updating the firmware of the machine that you have, keep updating the dependencies as well. Then we later on move to to the virtual machine. So in that case, some level of it basically provides you some level of abstraction. You basically allot what compute you want to allot to a particular VM, and as compared to a bare metal where compute you had to manually specify, VMs provided some level of abstraction on the layer of compute. You could have a huge server farm and you could allocate VMs to multiple services over there, and they would have some commonalities taken care for them already. From that, we move to containers, which you might have heard of. Docker is used for containerization. So what you do is you pack all your dependencies inside one image or one container, and everything is stored inside it. So if you take that container and you put it anywhere in any computer in the world, it would run as it is. It would not have any compatibility issues or anything like that. And later we move to another level of abstraction, which is functions, or which you will say serverless functions. So if you so rebriefing what I just said, increasing focus on business logic. So initially you had to spend a lot of and decreasing concern and control over the stack implementation. So in bare metal, you had a lot of concerns over how do you set up the servers and all that stuff. And but you did not get enough time to focus on what you really want to build. It took a lot of time to actually ship stuff, which changed over time. In functions, you have very low level of concern over what you need to take care of, and you could primarily focus on what you want to implement, what your actual app is, right? So this is a brief overview. Like in traditional, let's say even you go for VMs, bare metal, or anything, you have a computer in which you have running the front end logic, the back end logic. You have the set up the security on that VM. You also need to set up the database on that system. When you went the serverless route, all that is abstracted away for you. You don't need to take care of all that. These are separate services, right? So I'll code a few terms here. I'll explain what they mean. So the bottommost layer is bare metal. You need some PC to run on, which has a processor, which has a RAM. Then the next comes IaaS. IaaS stands for infrastructure as a service. So infrastructure as a service is, let's say you go to AWS or you go to Azure or Google Cloud, and you say, give me one virtual machine. You need one computer, but that is not a real one computer. It is running on top of some hardware at their data center, but on that hardware a lot of other systems are also running. So that is one level of concern above bare metal. Bare metal is a normal machine. On top of that, you'll add some layer of abstraction to get infrastructure as a service. Like you say, I need this form of VM, this VM needs this much compute, this much RAM, and you get an IaaS, which is an infrastructure as a service. On top of IaaS, you build other services, which is one could be platform as a service. So platform as a service is, let's say you need a database, you need a Postgres database, and you go to AWS or Google Cloud or anywhere, and you say, I just need a database. You don't need to care about what is running inside it. Is it running on an Ubuntu machine? Is it running on a Windows machine or whatever it's running on? You just say, I need a database, and they set up everything for you. They handle all the updates of Postgres. They handle all the underlying updates of the OS it's running on. You don't have to care about any of that. That is PaaS. That is for, say, you, for the basic example I gave is you get a database which is from a cloud provider. Another is container orchestrators. I'll not deep dive into much of that. And serverless sits basically at the top most level, at the level of abstraction. All this is just abstracted away from you. You don't need to care about anything. You just build what you want to do, and you don't have to care about anything else. So coming to a quick definition of what serverless is, and we'll break down line by line what that means. So serverless is a cloud native platform for short running stateless computation. So cloud native, that's like cloud based solution, not a regular solution. Not let's not consider that. For short running stateless computation. So let's say you want to fetch data from somewhere, like you need to do some small level of computation, but you need to do it again and again. You do need to do it multiple times. You need to do it at scale. But the function that it runs for say 1 second, 10 milliseconds, and it's stateless. Like stateless is that function does not retain its state. It could save it in another database or something, but the function itself does not have any state. And it's short running, right? So we'll come to why short running and how why we actually need it. And event driven applications which scale up and down instantly and automatically. So what I said about scaling up and down, so let's say you need a small amount of computation that you need to do periodically, or you need to do in batches at once. Say, let's say you are Amazon, and Amazon has, let's say, hundreds of courier services, and it needs to periodically update what is the status of your package. So they have API calls to each of the delivery services, right? But if they say deploy one server, and one server can say make 100 calls at any given time, that is very low for them. They need it at a million scale, right? So for that, you move to the serverless approach, which scales instantly up and down, and it scales to millions at once, or any amount that you can imagine. But you don't specifically allow compute to that already. Like in a VM, you already have compute allotted, and you use that to fetch stuff. But you are continuously paying. Let's say you're not even using the compute, you still keep paying for it, right? That is what serverless tries to change. And it charges for the actual usage at a millisecond granularity. Like I said, in a VM, you pay for, let's say you bought a VM, you run it for a month, you pay for every second of that month. You don't get, like, they don't give you a discount if you're not using it. But in case of serverless, let's say you deploy it for 5 seconds during day one, and you don't use it for the next 29 days, you only pay for those 5 seconds. You don't pay for that whole time. So, recapping what I said, servers are fully abstracted in serverless. Scaling is event driven, which and not resource driven. So, in a VM, let's say you would have to scale up a VM. What you would say is, currently I have 8 GB of RAM, give me 16 GB of RAM, and I'll be able to scale it. That would have been a VM approach. But in serverless, you don't say it's resource based. Like if my RAM is getting low or my CPU is getting low, you don't ask more of that. You say whenever an event happens, if I need more compute on the basis of that event, I will allocate more compute, and you only pay for what you use. So the popular platforms which provide serverless functionalities are mostly these. You can go through these, but primarily I'll say Azure Functions and AWS Lambda. These are the two popular ones. You can also check out Google Functions, but it's still a bit new. And there are some of the open source alternatives as well. Today we'll be discussing mostly about Azure Functions, but it is pretty similar across AWS Lambda and Azure Functions. So whenever you want to go and build your own stuff, you can use any of those. So let me give you a quick example before we jump into the demo or deep dive into more stuff. So let's say this is, you have a mobile app, right? And in your mobile app, you hit API endpoints to get data or fetch anything or do some computation. So let's say you need to do at slash customers, you need to do run this function one, and this function one, what it does is it goes to the database and it fetches everything and gives it to this API call. And you can actually separate out the logics. So let's say if you go to slash products, you can make a separate logical app out of it, which runs its own separate function. It's basically a easier logical abstraction. What you would have done in a monolithic sense would have been, you made a Flask server, you made the separate endpoints which you do the computation, and they're at one place. You don't have separation of logic, like say in microservices, you separate all the components into different microservices. They're not uh, overlapping one another. So this is to some extent what this helps you do without being concerned about what your stack would look like, what your deployment environment would look like. You just write your function, the small computation that you want to do, and you just deploy that to the cloud. So coming to what I said was event driven. So if this is a list from for what all events this Azure function support. It is similar for Lambda as well. So let's say it's Blob Storage, Cosmos DB. So what is Blob Storage? Blob Storage, you use Google Drive, right? Google Drive provides you some form of storage on the cloud. Blob storage is kind of similar, but it's used for actual computational purposes. So what you can do is you can set a trigger on the blob storage. You say that if a file is uploaded in this blob storage, download this file, edit this file this way, and upload it to this server. You can set this up. And how that happens in the serverless manner is, say you upload 100 files, it would 100 files would be parallelly processed in the way you want them to be. So that was one for blob storage. Another is databases. So let's say you set a trigger that in this database, when this entry becomes this, I want to trigger this serverless function. And let's say it function, what will do is it will go to all the other databases and it will, let's say, look for similar data, update the data. You can set certain triggers for that. uh, let's come to some basic examples. So one is HTTP and webhooks. So the example that I described here, this was more of an HTTP trigger example. So you have an HTTP API endpoint which you hit and you get a response in return. This is what we'll discuss in the demo today as well. So that is one. So there are certain applications in IoT as well. Let's say you have sensors running at some place, and you say that I want to keep monitoring this data from the sensor, and keep uploading it to a database. So if you buy a full-fledged VM for that, you keep paying for the whole time. But let's say your IoT device only makes requests every 5 seconds. You could use serverless over here, right? And so coming to another, which is queue storages. So queue, I assume most of you would have learned about what a queue data structure is. But queues in actual cloud sense are, let's say, job queues are there. You have a lot of jobs to be executed. You put them in a queue, and one by one, basically the compute will the orchestrator would take those jobs, execute them, and save the results or whatever is required for them. I guess we can. Another easy one is timer. So you can set it periodically. Let's say you want to fetch the temperature every 5 seconds. So you can make a function which runs every 5 seconds and fetches the weather from, say, weather.com's API and updates it in your app. So that is another form you can use it. Okay, let me see what I should cover first. Yeah. So I was just talking about the queue, right? So you have a queue of jobs, and we can call them messages, and you have an orchestrator. You don't need to understand what orchestrator is, but from the English point of view, orchestrator orchestrates all the all the work that is happening amongst all the different types of jobs. So what it will do is orchestrator, it will, let's say there are multiple jobs in the queue, and you tell the orchestrator at once run, let's say run 3 jobs at a time. So what it will do is it will automatically spin up 3 concurrent functions. They are separate from each other. They are running at the same time. It will provision them. It will send them the messages that the queue has provided it, and it will run the processing on them parallelly. It does not have to be sequential. You can run it parallelly. This is another example. Okay, actually, I should come. Okay, I'll cover this and we'll come back to fan in, fan out after the demo. So a few of the examples I just covered, the sensor data and the other examples, I can. This is a quick flow chart to understand. So let's say the tractor sensors send data to Amazon service, and you can set triggers on Amazon's this particular service. And whenever this is triggered, AWS Lambda, it would run a code to detect the sensor trend. You don't want this to run every time, but when you want to run it, gets triggered from this Kinesis service, and you run that function at that particular point of time. And this function, what it does is, let's say you need to place an order for replacement part, it will do that automatically. Another example is, let's say you build a social media app, and you post a status update, and so like I said, in the API's example, you have an, let's say, an HTTP endpoint. On the basis of that, AWS Lambda is triggered, and it runs the code that it got, and like whatever you need to do, and it further sends the notifications to the other friends that you have. I'll take a pause here to see if there are any questions, and then we'll move forward. uh, I try to explain once more what I said about parallelly executing. So if I assume you know to some extent what containers is, right? And in what I said was, you have a function, you need to let's say do some computation. Let's say very basic example, you need to do PNC, uh, permutation combination of, let's say, 39, any number. I give you an input and you need to do PNC and return me the result in your and let's say I give you very large numbers which takes it 2 to 3 seconds on an average computer, and I give you hundreds of these requests every second. Your regular computer can't handle that. It would take 100 into 2, let's say 200 seconds on your computer to do it sequentially. What I would do on a serverless function would be, it would quickly spin up 100 parallel containers. Each container would get one of the requests. They would independently execute that request, and let's say you want to dump that output in a database, it will parallelly dump that output over there. So in what would have taken 200 seconds on a VM, firstly it took you only 2 seconds. And let's say this request comes only once in a day, so you only pay for those 2 seconds for all those 100 functions instead of paying for the whole day for the VM. That is like a, I hope this example helps clear out what I'm trying to say. And we'll also go to the demo after this, and I'll take a pause to take some questions. Implementation, how are they able to scale up and scale down? Right. So that is the main thing is, in serverless, the beauty of it is you don't need to be concerned about how do they scale it up or scale it down. That is for the cloud provider to figure it out. You just tell it, let's say we are doing PNC, right? You just tell it, I need to do this particular code, execute this particular code whenever this trigger happens. You just need to provide the cloud provider this much information, and automatically, let's say 100 requests come, your cloud provider would automatically scale those 100 requests into 100 containers and process them. We don't need to understand how it scales up and down. It's for the cloud provider to take care of. Questions, guys? You can ask any questions you want. Anyone? Or should we move to the demo? Events, outputs of the serverless. Okay, events output. Actually, I can show you on the portal as well. So firstly, okay, you're primarily concerned about the logs, right? We have the logs on the portal, like whatever cloud portal you have, cloud provider you use, all the everything is basically logged in those. Shit. Guys, I need to just stop sharing for a sec. I'll just enter the password and get back to you. I'll show you the logs as well. If there's any other questions, still then maybe you can ask me, and we'll go through all that. I'll show you how that's executed. How do you push the code to the server? All that is actually how that's taken care of. If there are any other questions, please do ask. You can unmute your mic and ask as well. Just give me a second. I just need to enter the password. Yeah, guys, I hope I'm back. Sorry for the delay. Uh, yeah, any other questions till then? Else we'll jump into the demo right away. Okay, actually, I'll explain the fan in, fan out as well before we go to the demo. So, so like I said, right, you can easily scale it up and scale it down. But let's take the particular example of, let's say, shipping services. Like Amazon needs to fetch, it has, Amazon has 100 couriered partners which it uses to deliver stuff, and it needs to fetch the tracking information from all of them. So what it could do is, let's say, one function, this is only taking care of delivery, this one is for blue dart, this one is for, let's say, any other courier service. This is a long running function. It and let's say delivery has 100 packages in itself. So what it will do is, this particular function can further spin out 100 other functions which will fetch the tracking information. And once this is completed, it will inform this function that I have done, like all the 100 tasks have been completed, and you can log this data or store it in a database. So this is an example of fan in, fan out. Like you fan out the number of functions you make, you go to one layer, then you create more functions from that layer, and then you basically store the data from there. Typically, these functions are long running functions. Like I said, most functions are very small, in the order of a few minutes. These functions, for in particularly in Azure, these are long running functions. Let's not dive into that, but this is the basic concept of how you fan in and fan out to basically get better, to easily do what you want to do if you have a particular use case in mind. So let's take another example. So I told you about, there's a timer trigger, right? And say you set it at every 5 seconds, and you have an orchestrator, and the orchestrator says like spin three functions up, and each of these. So it's also mentioned here the example. So activity function to bill the customer. So three customers come, you spin up three functions to bill the like generate the bill. Then each of these functions transfers it to another function. It's just for logical separation. You don't want to do it in the same function itself. You anyways have a lot of compute, you can spin up another function for that. This function, what it does is, it sends the bill through the email. So these are all one to one for each customer. And let's say at the end, you only need to generate the invoice, and you can do this common for all the customers, and all these functions terminate, and one function generates the invoice, and one function eventually sends the final email that you have for all the customers. So this is like, these two are examples of how you fan in and fan out. Like this is very commonly used for serverless, and it is one of the most important applications in real life. uh, okay. Any other questions before we move to the demo? I'll wait a few seconds. All right, then I guess we can move to the demo part. All right, I'll take a fresh window so that you guys can also follow along. Uh, so if you would have installed the Azure Functions extension, it would have shown up over here. If you click over here, you'll get the Azure Functions thing. And what you need to do is firstly create a new project. Uh, yeah, it's setting up just. Yep. So let's say, right, so it gives you an option of all the languages. It supports almost all popular languages. For I assume that most people in this call would understand Python, so that's why I take the example of Python here. But you can use any language that you prefer, not C++, but other languages are still here. And say we select Python, and you can select which Python. Let's say you have Python 3.6, 3.7, or whatever. And yeah, so like I explained, what all triggers do we have? You can set all these triggers, it's here itself. Like it gives you an option what kind of template you want. Okay, Darsh, separate job containers for each function. Yes, Darsh, what I said was, I'll quickly open this. So you don't need to really understand if it's a container or not. It's completely abstracted to you. It's just a way I'm trying to explain it. You can imagine all of these to be running in separate containers. These are stateless. The state of this particular one has nothing to do with the state of this one. They are completely separate. They are not connected logically directly to each other. One, it could do something like you get an input, say A to this, it gives an output B. This output B is given as an input to this. So you get input output, or you, let's say, dump data in a database or something. But in itself, these functions are containers. They are stateless containers. They have no information as such which is key to them. Does that answer your question, Darsh? Cool. Okay, we were at the demo part. Yeah. So, right, I was saying like we have a lot of other triggers that we have, but I don't really think you guys would at this point understand how those work. So, the most basic one is an HTTP trigger, which we'll take for now. You can set a name for this function. I'll set it as this itself. So the next is the authorization part. So basically, if you set it, you can basically set it to be password like key protected or password protected, so that no random person can hit that API. Only you have that. But for the ease of use, right now I'll set it to anonymous so that we don't need to get into all that mess. And yeah, so it will take a few seconds, I guess, to set up this. Let's just. Meanwhile, if there are any questions, I'll be happy to answer them. Any questions, guys? Okay, maybe till then I'll show you what the portal looks like. So this is Azure portal. Like AWS could be similar, maybe a bit more difficult to understand. From here, where will we go? Resource groups. Right. So this is one function I basically deployed yesterday for testing purposes before I showed it to you guys. I'll maybe try to show what all info does it have. So you have one functions app, you have a storage account. Storage account, let's say you if you want to create a database, or you, like I said, each of these functions are stateless. So you would need some place, you if you want to dump data, you could dump it. So this is basically allotted to you already. You can use it if you want. And if someone was asking me about the events, uh, events. Okay, I have not set up many events for this, but we can set up events manually here itself. Coming to, where is it? Let me see if I can find that. Okay, we'll come back to that when it completes loading. So right now, I guess our app must be ready. Okay, cool. So this function is ready. So I'll quickly run through what the code looks like. So the main files that you'll be concerned about is this init.py, and there is this function.json. Others I guess you can mostly ignore. These are git ignore files. Yeah, these you can ignore. So what you, let's say you want to do that PNC log. So this is the main what you have. It's a main function, right? And what it's a HTTP request trigger which is set up for it. And what it does is the HTTP request that is sent to the Azure function is passed by this particular Python function. And in this demo, what it does is you can pass the name query element to it. I'll actually show you the deployed version as well. We can put this for deployment, and meanwhile we'll, yeah, demo 1, 2, 3. So this is asking for the location where I want it. So what I'm doing right now is I'm deploying it directly to the cloud. It won't run on my server. It will run directly on the cloud. While it deploys, like you can see, it's deploying right now. It will take some time for the first time. This is the one I deployed yesterday. So if you see over there, this is the trigger. This is the HTTP endpoint that we got. I'll copy this and we'll open it in the browser. right? So if you see this, like this HTTP function triggered successfully, pass a name in the query, blah blah blah. So if you see over here, this is a Python function. What was written here? If no name, this was the output that we got. This one. This is normal Python. You just return what you want to return. It's just normal Python. It's not being serverless does not add any level of complexity to it. It's just what you do regularly. You just put it in a function and you host it directly. You don't need to be concerned about what is installed, what is not, what is ready, what is not ready. You just put what you want in this here itself. And what it also has is, if you understand the method, the concept of a query element in URLs. Like if I put a question mark, name equal to say Anshul. So if you see hello Anshul, this HTTP request executed successfully. So this was the if condition over here. If name was provided, it will return this response. I hope this text is visible. Yep, this one. So yeah, so this is not like, so any form of computation. Let's say you want to do calculate PNC over here, and you evaluate and you return the response over here in this return itself. And as an input over here, we were getting name. We could get P, like we could get P, we could get N, we could get C, anything we want. Right, and I guess the other one must have deployed till now. Yep. So when you are deploying it, you can open this output window. It will show you what's happening behind the scenes in case you're interested, and it will eventually provide us that HTTP URL that we want. So what Harsh was asking is what happens behind the scene. Behind the scene is does set up all these dependent, like it's setting up Python, everything, but it's on the cloud. You don't need to be concerned about any of that. You just need to write what your code is and you just push it. So it's thinking blah blah blah. And eventually what will happen is when all that is done, you will get a link like this, whatever the name that you set up, and it's an HTTP API endpoint. So think of it like you are building an app. You quickly need to set up some REST API endpoints. You need a GET API to fetch data from the database. Very simple. One route you could do is you could like buy a subscription for a CRM service, or go a lot of use a Flask server, setting everything up. You set up Nginx on your server, you set up Nagrok or whatever you want to get it running. In this case, you don't have to set anything up, and it's really cheap if you use it very like the frequency of usage is very low. In most cases, it is very low. Like even in free tiers, it gives you tens of thousands of executions. And we can let me see if I can try to show you the interesting stuff from the dashboard. Let me see. So this is the resource group, right? Let me go to the resource. So this was our app. Let's see. Yep, events function. So we created only one function, but what you can do is you can create multiple functions in the same function app itself. This was the name of our function, and let's see what we can see over here. So you can see. Okay, let this load. So you can see the number of this is the execution we just did right now. This is at 10 5 10 6. The successful execution count. You can get all the logging that you want over here itself, the failures, the HTTP codes that were hit. Basically very easy to monitor if कुछ फट रहा है app में or anything like that. Let's see the other stuff. So this was the code. You can actually go and edit your code here itself. You don't even need VS Code to do that. You can go and edit it. Just click save and it will update that function. There is no need to, like, it won't take much time to redeploy it. Let's come to integrations. What is this? Yeah, so this is like a flow diagram kind of thing. So if you get this HTTP request, it will trigger this function, and this will be the HTTP output. So you can actually layer it out. You can do the fan in, fan out examples that I showed you. After function one, you can call function two. From function two, you can call function three. You can fan out, fan in, whatever you want. Let's come to monitor. Let's see what it has. Okay, yeah. So we can see how much time it took to execute the function. It's hardly in the order of millisecond, and this is the only time you pay for. You don't pay for more than that. In a day, only this many milliseconds of execution, you only pay for that much time. That is why people actually use it. You don't need a VM to use that. Okay, so that was the functions overview. Let's see what other stuff. So what? Let me try to answer any question that you might think of. So one question that I initially had was when I tried to use was, so let's say you need certain files which are accessible to each function. Like you need some files, some data dump or some keys or some special files which function needs access to every time. But in the function, like I showed you, there is only one file. You just write this code, right? Where do you put those files? You can put them in the server, like there are common storages where you can save all those files and your function can access them, so that is not a concern. And in terms of dependencies, let's say you want Python's libraries to be installed, you can do that as well. There are certain ways to do that. We'll not get too much into that, but all that can be done. So it's not restricted to just writing your code in a file. You can do a lot more than that what you do on your regular system. But just look at it how simple it is. You just write this, anything you want, just write it here and you deploy it. It becomes an API ready made. You don't have to take care of Nginx, any form of security or anything. Everything is taken care by Azure. You just need to push that. And okay, another file I'll try to explain is this function.json. So this function.json, firstly, it has the authorization method. Like I said, currently we are not authenticating it, it's open. We took an HTTP trigger. You can set any form of trigger. You can set a blob trigger, a database trigger, or any form of trigger. You can set the methods that the API call supports. Like currently we are doing a get request. You can do a post request. You can do any form of request that you want. And similarly for the output, let's say you don't want an HTTP output, you want another form of output. You can specify all those details over here. It actually gets a bit more complicated, whatever to configure. You can do anything you really want. Right. So let's come back to the portal and see if there's anything else interesting to show you guys. Um, right. So yeah, so this service is also ready. The one that I just started for you guys. Let me copy this and I'll put this in Postman. So in general, if you guys like before this, I showed it in a browser, but you can use Postman if you really want to do some like more in-depth stuff. You can send bodies, you can receive stuff in more complicated sense. So like the one I showed you, we can set the name here and sample, and we can send it. So you can attach content bodies over here, and you can act on that as well. We can see the output came like like I showed in the browser itself. But like I said, you can get the body responses, you can send the bodies, you can provide the authorization headers and everything. Everything is supported by it. Currently, so over here we just took the query parameters. Apart from that, you can get the body parameters and everything that you might need to make it more complex, to make it more rich in terms of functionality. Okay, and let me see if there's anything left to show over here as well. Okay. I guess I'm pretty much done from my end, guys. I wanted to keep this short so that it's not too overwhelming, and I can take some questions that we want now. Okay, Harsh, say I fan out to 10 different functions which use big libraries and are bigger rather than doing it. So Harsh, this is not for very big computation. I'll say like big file IO is it's not, because if you actually go to the runtime of these functions, let me see if I can find that. The runtime is limited to 256 MB of RAM, so it is not for very big IO. It's for a lot of operations that you need to do quickly. So I hope that answers your question. I can maybe try to. Uh, I'll show you the memory and compute that each container basically gets. It has a limit. Where is it? Right. So firstly, I'll come to the time thing. So these have a timeout of 10 minutes. I guess this is minutes, right? Yeah, it has 10-minute limits. Scale a number of instances. Like these are hundreds of instances. You can increase that. Let me see. Memory. Yep. So like it is a limit of the request size is limited to 100 MB, and let me see where the RAM is. Max memory per instance is limited to 1.5 GB in this case. And I guess that memory is shared across all the functions in a particular app, like 1.5 GB for that fan out. You can extend that, it's not much of an issue, but it's not meant to be in any case or form for heavy IO operations. It's for low IO operations. Right. Uh, cool. So any other questions, guys? Yeah, can dependencies. Uh, you can install the dependencies. I did it for C sharp. It's not very hard. I need to figure it out for Python how that works, but it's not very hard. You can, I guess it works both ways. You can do that zip approach, and you can also do it from the portal itself. It's not very hard. You can do that. Cool. Any other questions, guys? Like, I'll really suggest try building some APIs, whichever you use. Let's say you need to just fetch data from any site and you don't want to do it all the time. You want to, let's say, do it periodically, or let's say you build a phone app and you just want to fetch data. You can use that. Taking another example, like these guys were working on the Stop Stock app. Stop Stock actually uses serverless, in my opinion, like as far as I know, to fetch all those info, the scrapping thing, to do the scrapping, because you need that every minute, every second or something. You can't do that on a VM for thousands of users. So that is the approach I guess they also take. So you can extend that to your own apps and build cool stuff out of it. Any other questions, guys? If you have any questions, you can stay back. Otherwise, I guess we'll end the session here. You can mail me or contact me directly if you have any questions after this. I'll be happy to answer them.